Okay, before I get a little too carried away here, we got our part in. This is a Micro 29512WT. It's the adjustable voltage regulator we were looking for. And of course I got it from Master. I'm going to give you guys like all the parts and stuff to get at Master if you're going to do this, right? And it's better off just getting it from them, because at least you're getting reliable components most of the time. So there it is. I only got a single chip, right? Same price you can buy on eBay, or I think it's cheaper than Amazon maybe. But anyhow, you get a protective cover and everything. So there's our piece. I'm working on the PCB, well, I'm doing breadboard first, right? And then I think what I'll do is I'll move it over to a perf board. And of course, here's the schematic. And we'll go over some of this other stuff a little bit later. So somebody asked me about the schematic for my setup here, run the power supply to my Pi. And I'm actually going to do something a little different. And since I'm going to do this anyways, I'm going to go ahead and I'm going to throw on a switch. And we'll get that going. And then I probably ought to put some protection on there. So I'm going to go ahead and do an inline fuse. And so basically what I have here, right, is I have 64 inches of this extension cord that I've turned into my power supply, right, my input. And this is about 27 inches that goes to the Pi itself. So what I could do is I could put this down on the lower stand, and I could put the battery on the floor with this long cable. So some of the things I have to take into account by doing it this way, right, is I have voltage drop in each line that I have to account for. So originally, my schematic was this, okay? So this is a very easy, simple schematic. It's just the MIC 29510 that I originally talked about in my first video. It's just got an input capacitor and an output capacitor, which I think that's a 47 microfarad, but whatever. It doesn't matter. I'm changing this out anyways. And I was getting 4.9 something volts on the output. Well, I went ahead and added this on there. I made this a little bit longer, and really I want to make it even longer. So I'd like to put on an even longer cable. So this is like a 6-foot USB cable. And some other things I wanted to do is, like I plan on putting a Peltier thermal cooler on my camera, right? And this is kind of like my little mock-up that I'm doing right now, that I'm considering, so I can cool my camera. So I need to run this, and this is 5 volts at 5 amps as well. So I think what I might do is, with my power supplies, is I might actually show you the inside, right? I showed you the schematic. So there's what it looks like on the inside, right? It's just really simple. A couple capacitors, the MIC in there, and that's it, right? That's exactly what we have. Input, output. This is really simple. And I put it in the middle. So like I was saying is I want to run, I will probably keep this MIC not in here, but I will use this MIC to run my cooler on my camera, so my Peltier cooler, and I'll probably move it, I don't know, maybe over here or somewhere else, right? And so the other thing I have to keep in mind is heat generation. So these are my batteries that I was showing you before. These are 8.2, I think it was. I don't remember exactly off the top of my head. When they're fully charged. So 6.90, I think it drops down to 6.8. Eventually it settles at 6.47, I think, or something like that. So I have to account for voltage drop from 5 volts or 6 point whatever, 8 down to 5 volts. So I have to do a lot of thermal regulation. The case is metal that I have here, or aluminum, so it helps with the dissipation. So what I may do is I may put the 512 up top, or I might do something completely different and put this 512 up top, use it to run other power supply things. Like I'm debating about putting motors on for the autofocus and all that other stuff, right? Like, because I have a Pi, I can do whatever I want. So I'm thinking about doing autofocusing and all that other stuff, and even like running the equatorial, the motor mount, Celestron motor mount, like redoing it and having the Pi control the motor mount. But anyway, that's a lot of future thinking. So I have this. I'll probably put that up top. I'm even debating, I don't know if I can find it. You got to ignore the mess. I have so much stuff that I keep going on, and I got Halloween coming up that I'm trying to do some animatronic stuff with. And I'm not sure where I put it. Well, anyways, the other thing I might do is oh, here it is. I might do this buck regulator, right, to run the thermal Peltier cooler. So I can run it with this. This will be a lot more efficient. Then maybe I might need to get a bigger case, right? Because like if I try and put this in here, I mean I could put this in here. I gotta work out the thermals. Put that up top, and then my other regulator that we're gonna make up right now, I could put it in the bottom, and then that might work too. So anyhow, these two guys, this will be for videos later, right? Today is going to be this, and getting this going, and the new circuit that I'm working on now, right? So here's going to be the new circuit. So I put in 100 microfarad on the input. We're going to have a diode going from the output back to the input because we have a 1000 microfarad capacitor here. So if this gets shut off and this is charged, it'll drain back in through here, but it should be plugged into the Pi. I mean, unless you unplug the Pi and then disconnect this, then this stays charged. It'll discharge back in through here. And then we have this, right? So right now, I think I'm sitting at 5.14, and these are not binned, so these capacitance could vary a little bit, right, between those. I went ahead and I binned out a couple capacitors here with my LCR meter, and I have some actual exact values for my 3K3 and 980. So I have those here and here, right? So I may end up changing my voltages to 5.47, and the reason why I do that is because, like I said, I want to put a longer cable on there, and I need to account for voltage drop over this. This is a 6-foot cable, but anyhow, I've got it set up for 5.14 now. This is the exact circuit I have right now, and I built it up right here, right? So I have the heater on it, which this will get taken off and it'll get put onto the case down there, and I'll just take that one out, and it'll just sit just like that. So there's the diode from our schematic here, our 1N4007, and then there's our capacitor and our part of our resistor here, our resistor divider. So this would be R5. And then we have the output capacitor, the input capacitor, and then inside there you see there's another diode. Hopefully you guys can see that, maybe not. So anyhow, that's kind of the plan today with this. This is the schematic. We'll just get it built up and get her going, and then go from there. So our big thing here, right, and this doesn't matter, and this is a 15 amp. I probably should change this out, put it down to a 7.5 amp. Which I don't know if I have one of those available or not. I have to look at my fuse things. So anyhow, I don't even know. Yeah. Some of the solder work stuff, like I use Kester solder. I'll put links in the description below for all this stuff. This is the solder I like using. The stuff I'm gonna put in below, I think it's 6340 something or other, or 47s, I don't remember exactly, but anyhow, 6337 I think, I don't remember, but anyhow, it's a very small tube. You shouldn't need a whole lot, like I don't know, this is a pound or so, and you guys just don't need that much for what you're doing unless you're doing a lot of electronic stuff. So anyhow, oh, where's my screwdriver? Okay, so anyhow, so my screwdriver, So this is another little project box. It's just a switch. What this will help me do, so like right now I'm just unplugging and plugging in and unplugging in, and it's wearing out my connector, right? So I'd rather just have a switch I could flip it on and off, on and off. So what I have here is we just need to come in through one side and go out the other, and then so I'm not quite sure how, but I think we're gonna put it, I've been debating, do I put it up here or should I put it back here? And of course, we'll put it on the high side, so we'll put it on the positive. I'm thinking we put it here. So I need to go this way. Alright, how do we want to do this? Come in, now we'll come in this way, and then we'll go out this way. So we'll do this. So we'll go to this pin, and then from this pin out, this will go to this pin. I think that's the best way to do it. Oh, I should get my drill. That's right. This is up to temp, so. Oh, I got what a mess. So much stuff. Oh yeah, and like if you get the solder, don't use the sponge thing. Just get this thing. I think it's like $4 or something. And don't do the sponge thing, right? Always get your tip where it's nice and chunky. Not gonna do a solder class, but I don't even know if you guys can see what I'm doing. Barely, huh? So I just put the solder on the other side, melt the solder. I like to run it a few times there. So there's that done. I don't know what, I think I'm set at 400 maybe. So, yeah. Looks pretty good. I don't know how much I'm going to edit out, but anyhow, so we go like this. I think we'll go into the switch because this should be as close to the battery as possible. Wonder what did I do with that lead? Maybe I just put a new crimp on here. Right, we'll put our switch in here. We'll come out of here. This can be whatever length, it doesn't matter. I think I'll just take it, I'll take it where it is, right? I'll leave it where it is. Because if I have to do any more cutting or clipping or removing, or if I change the plug connectors, that still gives me room to work with. I'll just do that. What am I doing here? Alright, you. Both those are done. That's done. Since we're on the high side, I like to stick with positive or red, so that way everything's not confusing. What does what. I'll give you a thing in the crimpers. These are my crimpers. I've had these a very long time. I really like them, but I don't think you can get them anymore. So I will put it in the description, like I said, down below for all this stuff. So the other thing I like to do is I like to bend these tabs down a little bit. Because they are pretty high up. I want a nice solid connection with my tools. So when I plug stuff into here, right, I want a nice tight fit. So, oops. Oh yeah, so the other thing, right, like these batteries are great, but if I like put a Peltier on there and I put other motors, you know, I'm going to have to get a bigger battery because this is only 7 amp hours. This will run a long time if you're just doing the camera, but if I'm going to add all this extra stuff on there, I'm going to have to look at like 100 and something amp hour, or 120 or 130 or 200 amp hour batteries, and then I'll be able to run the thing for a long time. So anyhow, I'm considering that as well. So let me come back. We're going to do this in here like this to this pin. But I need to drill a hole. So I need to measure. I'll be right back. So what we need to do, right, is we need to measure. So that's pretty close. What is that? 7/16? 1/8? Oh, it's 1/8. So I'll do a 1/8 hole. Let's see how we're gonna do this. We're gonna do positive in here, go negative out there. Do I go straight here or should I go here? I think we'll go here. It's going to be the easiest way to do this. If I go here. Yeah. Look at my drill. Alright. So what I'm doing, right, is I'm considering putting it near the bottom. So I need it as close to the bottom as I can get it. I'm not going to do this in my hand. Okay. That got me so far right. So I got a little nick there. So if we go in there, we're going to come out over here on this side. Cool. So now what we're going to do, I get my little needle files out, right? Since this one I sort of messed up on. I'll just make some microplastics here real quick. That should be enough to get that in there. Yes. And then this other one, we'll just clean this one up just a little bit. So now we have that on the bottom. That's going to have to go into this. So I need to make sure that slots in there perfect. Looks good. Yep. So the big thing is getting this. Maybe I should have not done that. I could always put it on this way, bend her out. That'll work. We'll just do that. Let me cut this down a little bit so I don't have quite so much. Turn my solder gun up to 500 or, well, yeah, 500 Fahrenheit. 800 Celsius. Or no, 800 Fahrenheit. About 400 and something Celsius. Just gonna put some solder on the end of these guys. And these might have to have some little bit of dwell time because they are pretty thick. There she goes. A little too much dwell time. Hopefully we didn't mess that up. Double check. Those probably won't grab. Let's hope we didn't mess the switch up. Now we turned it into a momentary. Uh-oh. Does it actually even work that way? Yeah, it does. Alright, well, whatever. I got another switch. Pop it out, right? It's very simple. You just press the tabs on this side. I'll throw this one away. I'm not gonna mess with a broken switch. Especially if I want a momentary, I'll just order one. Cutting this out, I just used a utility knife and just kind of edged it and then took my needle files and filed it. Where's my... Uh-oh. My last switch. Oh, you know, maybe that's the other, you know, whatever, guys. I was debating, you know, like, do I want to switch on this way? Or do I want to switch on this way, right? It doesn't matter. Alright, you. Let's get this back on here again. It's not destroy our switch this time. That'll work. Let's see, we're going to take this one in. Put it on that side. It'll be fine with me. Ouch, that's a little warm. And then we'll just take this one. Just do the same with that. Bend her at an angle. Put it on this side. Ideally, I want to heat both these up at the same time. So now we have a good connection there. Put our meter on ohms. And then if you press the select button, it puts it on the beeper. No continuity, flip the switch. Continuity. We're good to go on that. That's done. So there's one connector switch done. And we just take this. So these holes here and here, right here and here. So it's going to go this way. So one thing with these plastic screws, if you've already threaded or started threading, if you back them out first, you'll feel them and you'll sometimes hear them if you like really threaded them. And then you'll feel it pop into place and you'll hear it pop into place. And what that means is you're not creating new threads and you're not destroying your original threads. Just so you're aware of that. Alright. I kind of really didn't thread this. And if you push and turn, you'll hear it and you'll feel it go into the old threads, and then you can start screwing. Especially if you take plastic stuff apart a lot, right? Alright, there we go. On off switch. Protection switch. Positive, negative. On off with our diodes. So cool, cool, cool. This is just extra. I'll put this in my wire stuff. That's for some other stuff. This thing I'll just throw it away. It's sticking now. I don't know. I hate to keep it, it's already damaged. I'll just throw it away. It's not worth it. It's only like, I don't know, $3 or something. Whatever. Trash. Get rid of it. Okay, oh, we got microplastics. I'll put those in a pile somewhere and get them swept up. Oh yeah, next thing. So, let's see. We'll leave that in. Where's my other tools? Oh. Alright, I found them. So I just need to get this one. Nope, too big. This one. Nope, way too small. This one for sure. That'll work. Oh my gosh. Oh. Oh yeah, whoopsie. I forgot I super glued that. Super glue doesn't like heat. I don't recommend doing this. It's got a lot of bad fumes to it. Get it in your eye, it burns. You don't want to breathe it either. It's probably nasty. Why did I super glue that? I don't know. Okay. I need more tools. More tools. Okay, sorry, I'm back. Well, I've been back. I didn't want to, so I got a couple different tools, right? So I had to get one for this that fits in there. I haven't done it. So yeah, you're not missing out on anything other than me trying to find the right tool. So we're going to do that on that. And then we're going to do this over here. Because I don't think my little screwdriver thingy is going to work very well with this. Getting this off of here. I really need some power. I don't know why I did that because I never put any thermal compound below. So, and this wasn't going to be permanent anyways. Maybe I just decided to do it just to be safe. Because I had been using this for, 2 weeks. Okay, so now we need to get rid of this. This is my input, right? Coming off the orange wire and put out of the battery. Do we need, yep, I need to remove the inputs. Oh, I just knocked all that over. It's going to take a while. I don't have a very good thermal tip here. It's a lot of solder we got to get through too. A lot of metal's got to get heated up. So just got an extra long dwell time. If you don't have a solder iron for this part, you don't need one. You can always put some clips, right, and clamp it into the screws there, or the nuts. What are we doing? What am I doing? Right, there it goes. And the outputs. I'm gonna have to clean that mess up. So, and for this thing, I'm gonna just use this. Now I think, nah, I'm not gonna do that. I'm just gonna, for now, right, that's not the right size. I won't fit it either. And I can't go through that because I just made those a mess. Am I gonna get lucky? Oh, I got lucky. That one was still there. So I need the heat sink, and I use the case as a heat sink, but I don't need the heat sink on here, right? That's just for testing, when I was testing it. So you see this is what we've got. This is also the ground. I think I'll go ahead and just throw a dab of thermal paste on here. I'm just using regular CPU thermal paste. Just put a dab on there. Doesn't take much. You don't have to go too crazy with it. And I might even, like, you know, you saw, I might take this off and change it anyways. Change my voltages because I'm not sure what I'm going to get per voltage wise. So inputs, smaller input, outputs, bigger outputs. So, I'm going to tilt this up a little bit more. Just to make sure I don't short anything out. Where's the, what did I go, here it is. So I think this one I'm going to have to do this. Go through this way. That's interesting. I don't know. I don't think that'll thread that way. We'll see. Sorry, I know this is very difficult to see what I'm doing, but... Just kind of holding the... I don't want to do anything too permanent just yet. It's only temporary because I want to see exactly what I want to do, right? I want a low enough voltage drop, but I don't want to have too much. Because the Raspberry Pi, and I'll have to show the documentation, right? Or where some of it's discussed. I have certain leeways for the Pi on inputs. Like 5.6 volts is the absolute max. Or something like that, right? I should shorten these, to be honest with you, but we'll leave them long for right now. It gives me room to work with. How you doing, Kit Kat? Ouch. Gets hot, hot, hot. This. It's definitely going to get cut. So I'm just using some side cutters. Works really good cutting. Wish I could side cut more of that off there. I have so much. Can't put a bend on it. And I'm just using the solder that was already on the pins. I probably should put some new on there, but good enough for right now. You going back to bed? Poor Kit Kat. Am I disturbing your sleep? There we go. Well, so there it is. Now, you know, it shouldn't, we gotta be very careful. I probably ought to put some plastic back here. So we'll just use this. This is just like cheap cutting board, right? Works really good for projects. Just make your own little dividers, right? So I just stick this in here. Well, probably do the, get the height down too, huh? Oh, a little too long. Oh, that's all right. Let's do that. Still a smidgen too long, but uh-oh. Didn't cut straight. There we go. So let's see. Negative, positive. Actually, I pull out a nipper. Don't leave that. Don't leave anything floating in there. Sorry, I'm bumping the camera. Negative, positive, negative, positive. Input, output. Good to go. Except for I got a little too high over here. So I need to take a little bit off both sides. Probably a little bit both sides. Yeah, it's just not gonna cooperate. Let's take it down to that line, I guess, or the double line. What's really good is they got lines on here, right? Both directions. So you can kind of just follow the line. There she goes. Perfect. Let me just put this screw in here. You know, I'll do some thermal stuff on this maybe later, because I debated I can actually put can put this on a 12-volt battery if I needed to in a pinch, but I'd have to do the thermal math to see how much heat generation is going to be. And then, so anyhow, there we go. Got all of our battery connectors here. Actually, you know what? So what I should do, since I can do this, is I can make sure I don't have a short. I'll just use this. This will work. Not run a lot of power through it. I'm just gonna take, oh, that's positive, but negative. This is not behaving. Gripper tool. The same for this one. My gripper tool. So now what we have is a test pot. Add batteries to there. That's to there. Yeah, I just take this, I'll put it in my power supply. Now I tell my power supply to be a 7.5 volt battery. We'll turn the current down to 1 amp, just in case we have a short, right? So now we have this pretending to be a battery. This is our switch. We don't know whether that's on or off because I forgot to test it. And then we have our output here. And we can also test what we're getting on these. So I'll put the voltmeter up here. I'll put this way so you can read it. Turn the power on. Now we're putting out 7.497 volts. We're getting nothing on the output, which means our switch is off. Turn our switch on. We're getting 5.15. So 5.15 volts. Good to go. And we're drawing 5 milliamps. Yeah, and that's the regulator. That's fine. It needs a little bit of a draw to regulate anyways. Oh, there we go. So, there we go. That's all we got to it, right? And so, like I said, if I need to, this is probably 5V17 instead of 14. I probably wrote that wrong. If I need to, right, I can test with what. Turn this off. to leave it running. I will test this like it is. This is better than the Make 29 510 that I had before, because this was only limited to 5 volts. Now we've accounted for a little bit of voltage drop on the output. I can probably put on a longer USB cable. If I want to try and do my 6-foot cable, oh yeah, and so these cables, right, you can see like here's a white, and here's the, actually I'll do one. Where's it at? Where's it at? Here we go. So if you order this cable that I have down below, this is a 100 watt. This is 100 watt. I think this is 100 watt. This might be a 60. I don't remember exactly. I'll have to look. Well, I'll post it in the thing. Whatever. It'll be the right cable. So you see, this is the one we don't need, and we need the USB-C for the Raspberry Pi. So what I will do, right? Of course, I like to have a little bit of extra cable down here. This is a 6-foot cable. I'm going to take off probably 6 inches or so. Just cut the cable. I have a cheap, easy tool to get this off here, but anyhow, so you don't need the white cable. You don't need the green cable. And obviously what's left is, that's negative, that's positive. So what I do with the white and green cable is I don't cut them even, but I'll cut one really low, and the other one I'll cut a little high. Probably don't leave any strands sticking out of there. And then what you ought to do is just make sure you go ahead and tape it up, right? I know I didn't do it on that one, but just tape it up a little bit. So that it stays. And then there's your positive and negative that runs your Pi. And there you go. There's your long cable, right? Ideally with these, now I just grab these and use my fingernails. It's not too hard. Okay. It's just sort of difficult. And you see how it frays? So go ahead and just twist it. And this is copper, right? This is not the tinned aluminum stuff. This is the good stuff. So we'll just do that, right? I'll take my solder, I'll bend it up where I got a little thingy. Now this won't take very long. We'll tip my tip real quick. Actually, I'll clean this off. I haven't cleaned it in a little while. Get some tinning on there. Now this wire will heat up really quick. Matter of fact, it looks like it's just sucking it off the iron. Alright. Do the other one the same way. Pull it off, twist it. Ah! I'll pull a little solder on my iron. Oops. Just touch it to both. Nice tin wire. Gets hot really quick. And then I could just switch it out. Now I have a 6-foot cable, right? Anyhow, so there it is. I hope that helps you. And we'll see you later. Bye.